Hello and welcome to Mad Science Gaming. Emphasis on science today as I take you through what it is that makes me think I'm qualified to talk about science on YouTube. To start, I do not have a doctorate, nor a master's, nor even a bachelor's. So what makes me think I can talk about and perhaps teach science? Because I love science, and because I have studied electron microscopy from San Joaquin Delta College, SJDC or Delta for short. Most people would have one main question at this point. What is electron microscopy? Put simply, it is the usage of electron microscopes. For those unfamiliar with this field of science, electron microscopes are powerful microscopes, some of which can even see atoms. What I've been studying at Delta was how to operate, maintain, and prepare samples for these amazing tools. The best part about the program I went through is that they had electron microscopes there for students to work on, and this is at a community college no less. Each student got assigned 1 hour per week as their microscope time to spend alone with at the microscope, finishing assignments, or sometimes just refreshing what they know. And the pictures seen throughout this video have been what I consider my most aesthetically pleasing microscope pictures, or micrographs, that I took in Delta's program. You'll notice that they're all in black and white. That's because these instruments detect electrons. They choose what grayscale value based on how many electrons hit the detector at that spot. But before we go any further, I should talk about the different types of electron microscopes. The two main types of electron microscopes are TEMs, or transmission electron microscopes, and SEMs, or scanning electron microscopes. These collect data in very different ways. We'll start with the TEM because it's easier to relate to the light microscope most people have seen in their biology class. TEMs transmit the electrons all the way through the sample, as the name suggests. However, in order for the electrons to pass through the sample, it has to be extremely thin. An average thickness of a TEM sample should be under 1 micrometer or less than 1,000th of a millimeter. The TEM starts by shooting electrons out of a high-voltage electron gun. They get squeezed down as small as they can, coming to a focus on the sample. The electrons then pass through the sample. They get spread out by electromagnets, resulting in magnification. They then do either one of two things, depending on what the operator has selected. They either travel down and hit a phosphorus screen, causing it to glow and make a picture, leaving darker areas where the electrons did not pass through the sample easily, or they get converted into photons and sent into a camera for imaging. Now on to SEMs. SEMs scan across the sample, hence their namesake. The SEM samples do not have to be thin, but they do have to be electrically conductive, and I'll explain why in a bit. SEMs start with the same electron squeezing into a beam that finds its smallest point on the surface of the sample as the TEM. That's where the similarities stop, though, as the SEM creates an image by moving the beam across the sample in a rastering pattern, meaning it will move the same way monitors and TVs draw their pixels, one at a time, starting from the top left corner, moving to the top right corner, then down a row and repeat the left to right motion. The SEM uses this pattern to make an image. It does this by detecting the electrons that got ejected out of the sample by the force of the electron beam. It then takes the concentration of electrons and gives it a gray value and moves on to the next area, or pixel, of the image. Okay, but why does the sample need to be conductive? The first thought that might be that non-conductive samples wouldn't lose any electrons from the beam, and that's not too far off from the real reason. The reason samples need to be conductive is they need to have a place to direct the massive amount of electrons from the beam, because if they can't get rid of those electrons, then the sample builds up a negative charge that starts to deflect the position of the beam, ruining the image. In most cases, this can be overcome by coating the sample with a conductive material. The most common ones are carbon, gold, and a gold-palladium alloy. I hope that gave you some insight into the world of electron microscopy. If you have any questions or concerns, leave them in the comments below. Have a good rest of your day, and I'll see you next time.